little later. There are just two more words here. One is bit and one is baud. The word bit was not in the Webster's dictionary in 1940. It was coined by a professor named Claude Shannon at the Massachusetts Institute of Technology. He is the greatest professor who wrote the theory of handling intelligence, and he coined the term of binary digit and invented a word that became an English word now. And a binary digit is called a bit. Then later on along came Émile Baudot, a French telegraph engineer, who introduced a 6-bit code, and the 6-bit code was transmitted with mechanical keyboards into wire pairs owned by the telephone company. And in his honor, the rate at which we signal is called the baud. So the baud is for Baudot. If you write BD, you are supposed to write capital B because it's the name of a Frenchman. If you write baud, then it's all lowercase because it's just made up, right? Bauds and bits, they relate in such a way that baud is the rate at which you signal, but the rate at which you may create 8-bit code or 6-bit code. So the actual bits per second is the rate at which you create several bits. So the bits per second is the number of bits in your system multiplied by the rate at which you create them. You create bits by typing at a keyboard. A unit called the terminal node controller gathers all of your bits and puts them into words of 6-bit or 8-bit, and 6-bit and 8-bit words like chunks are sent out with a rate called the baud rate. And then what's a modem? Well, bits cannot go to the microphone input. Your microphone creates voice, so you have to create fake voice. So digital mode uses the terminal node controller to trigger audio frequency oscillators, and then audio frequencies go into the microphone input, and your radio would not know if you talk or if that's a digital mode. For the radio, it's all audio frequency. Next up, please, at the end of this, we better stop. I'm illustrating here the meaning of synchronous and asynchronous communication. In synchronous communication, we have a long packet of data, say 40 bits. And after a chunk of 40 or 128 bits or so, there's a single sync bit added. So synchronous communications take place on a message basis, whereas asynchronous communications is like you packing at a keyboard. Like me, I'm still typing with 2 fingers. I'm not a touch typist. Even a touch typist hits one key at a time. Each time you press a key, you would create a code. One popular code is the ASCII code, and another popular code is the Baudot code. The Baudot code is a 6-bit code, and each time the RTTY operator presses a key, a 6-bit code is created, and then the 6-bit code is supplemented with a start bit and a stop bit. Following the stop bit, the line is idling, even as long as it takes you to move your finger from one key to the other. So the communication is asynchronous because each time you pack on a key, you start with a start bit, there comes your 6 or 8 bits, then you have a stop bit to tell the line that this is it, the next character is coming. And then errors often happen in transmission, so we introduce an error correction method, and the method is called the use of parity bits. Now, parity bits, they go by a convention. the convention is even parity or odd parity. Let's talk about a Bordeaux code. 6 bits, and a start bit, and a stop bit. Altogether, that's 8. But 8 is a even number. Okay? But you can stuff a 9th bit. A 9 is an odd number. So therefore, you made the 8-bit artificially odd. But you can choose to stuff a parity bit for 0. Then you don't alter. So the parity is whether the total number of ones in a code word is an odd number or an even number. The last example, if a word is 1111000, was this odd or even? 111 is 3 times 1, so that's an odd word. But you want to make this even parity, then you stuff the parity bit as a 1. Now you have a 111000 and a 1 at the end. Now you have 4 ones and 3 zeros. So if the parity is set odd at the transmitting end, it must be set odd at the receiving end as well. Then the receiver looks at the bits, counts the bits. He said, wait a minute, I'm set to even parity, but I'm getting 5 ones, and the rest is all zeros. That's odd, so something wrong. An erroneous bit was transmitted. So the receiver can send an error message back to the transmitter, please retransmit that last code because it wasn't right. So parity bits are used for error correction. Well, I will explain the power issue Thursday, and Thursday we wrap up receivers. And that's it. And then we have a review some other time. So thank you for being here and staying with me to the end. See you Thursday.